This next piece is the final piece, but this is the new part that you haven't learned yet because the previous two videos were all review. This is where we're getting into dependent events, which we haven't taken a look at these situations yet. So we have Kaya. She needs a pair of socks in the laundry basket of unfolded socks. And in this basket are 6 red socks, 12 pink, 8 white, and 4 multicolored. And we need to calculate each probability. So the first step is still going to be to calculate and find the probability of A happening. Then we will, this is where it's different, we will find the probability of B happening after A. This means we're assuming that A is going to occur. This is going to change up our denominator and we're going to take a look at that. And then finally, just like we've been doing, the third step will be to multiply the two probabilities, simplify, and then convert to both decimal and percent. So we have here that we need to find the probability of getting a pink and then a red sock. So if we look here, we have 12 plus 8 plus 4 plus 6, which is 30 socks. And so I'm going to start by having our denominator of 30. And then of those 30 socks, 12 are pink. Now we're going to assume that we then pick that pink sock out of the laundry basket. And so now we no longer have 30 socks in the laundry basket for Kaya to choose from. We now have 29 socks. So this is kind of looking like what it did when we were talking permutations in that the number decreases. However, we still have all 6 of those red socks. So now it's going to be 6. So when we multiply, and I'm actually going to simplify ahead of time simply because I don't want to multiply 30 by 29 and 12 by 6. So if I do that, I know that 29. So that means that I can take 30 and I can take 6 and divide them by 6, which gives me 1 and gives me 5, which is going to make my life a whole lot easier to multiply. So then 12 times 1 is 12. And 29 times 5, well, I know 9 times 5 is 45. Carry the 4. 5 times 2 is 10, plus 4 is 14. So it is 12 out of 145. I'll let you take care of finding the decimal and the percent. Now this next one, we want the probability of drawing a white sock and then another white sock. So we see here she's got 8 white socks to begin with out of the 30 in the basket. New problem, we now have 30 socks in the basket again. So we have 8 out of 30. Now we're going to assume that she has drawn a white sock. That means that not only are there now 29 socks in the basket, but there are now 7 socks in the basket that are white because we've already selected one of them that's white. Now here's a situation where we aren't going to be able to simplify because 29 and 8 have no common factors and neither do 7 and 30. So I'm going to go ahead and multiply. I know that 8 times 7 is 56. And then what I'm going to do is, because I know a lot of you struggle with big numbers, let's take 30 times 29. I'm going to take 29 times 3 and put a 0 on the end. So I know that I'm going to have a 0 on the end. 9 times 3 is 27. And so I'm put my 7 there. And carry the 2. And then 3 times 2 is 6. Plus 2 is 8. So we have 56 out of 870. And so we can simplify that. They are both divisible by 2, which gives me 435 on the bottom. And then on the top, divide by 2, you get 28. And I'll let you go ahead and get the decimal and the percent for that. Now this final one is the probability of picking a multicolored sock and then not a multicolored sock. So if I look at this, we have out of 30 of our socks, we have 4 that are multicolored. So that means that I have 4 out of 30, which I know is 2/15. So I'm going to use 2/15 instead. Now, once I've done that, I now am down to 29 socks, and I'm down to 3 multicolored, which means that if there are 3 multicolored, there are 26 that are not multicolored. So I'm going to put the 26 on top. Now when we go ahead and multiply these, 2 times 26 is 52. And then 15 times 29. That one's a tough one, so let's do 15 times 29 over here. I know you probably have a calculator. I don't have one handy on me. 9 times 5 is 45. Carry the 4. 9 times 1 plus 4 is 13. 5 times 2 is 10. Carry the 1. 2 times 1 plus 1 is 3. So that means that I have 435, and I will let you take care of the decimal and the percent. Moving on to our last example. We have 1 freshman, 2 sophomores, 4 juniors, and 5 seniors that receive top scores in a school essay contest. Now, we need to choose 2 students to read their essays at the awards ceremony. So they're going to take their names, throw them into a hat, and choose 2 of them at random. Now remember, this means we're not replacing the names. Like last lesson you had choosing tiles out of a bag, where you would choose a tile, you would record it, and you would put it back. So it didn't change how many were in the bag. Now we're going to choose that name, we're going to set it aside because we don't want to choose their name twice. So we want to know what's the probability of choosing a junior and then a senior. So we look here. If we've got 1 freshman, 2 sophomores, that's 3 students, plus 4 juniors is 7, plus 5 is 12. So we have 12 students, and out of those we have 4 juniors. And then once we choose that name, we are now down to 11 students in the hat, and 5 of them are still seniors. So we have 4 12ths times 5 11ths. I am going to go ahead and simplify this. 4 12ths, I'm going to simplify this down to 1/3 because it's going to make my life a whole lot easier. 1 times 5 is 5. 3 times 11 is 33. So 5 out of 33 chance. So I'll let you change that into decimal and percent. Now we've got the probability of choosing 2 seniors. Now we have 12 students whose names are in the hat, and of them, 5 of them are seniors. If we assume that the first person chosen is a senior, that means we are now down to 11 students in the hat, 4 of which are seniors. So if we go ahead and simplify ahead of time, 12 will become 3 and 4 will become 1 to make our lives easier. And once again, we have a chance of 5 over 33. How crazy is it that changing it from junior and a senior to 2 seniors is going to have the same probability? The final one is the probability of choosing a sophomore and then not a sophomore. So I look here, I have 12 students again, and out of those 12 students, 2 are sophomores. And then if I assume that a sophomore is chosen, I'm now down to 11 students, and 1 of them is a sophomore, which means that there are 10 that are not sophomores. So that's going to help us out. So then when we go ahead to simplify, I'm going to say, well, I know that 12 and 10 are both divisible by 2, which will give me 5 and 6. But I also know that 2 and 6 are divisible by 2 to give me 1 and 3. And so that will give me a 5 out of 33 chance yet again. How crazy is that? Your job now is to go ahead and try these you-try problems. and determine if the events are dependent or independent. You can just write a D or an I next to your notes, and then calculate their probabilities.